Hello, this is Charlene. In this video, we're going to be talking about slope-intercept form of a linear equation. Our information here tells us that the slope-intercept form of a linear equation is y equals mx plus b, where m is the slope, and the slope is defined as the constant rate of change, and b is the y-intercept, which is the initial value. So here we have our slope-intercept form, y equals mx plus b. But before we go on in this video, I need to make sure that we think about a couple of things going forward. This is a linear equation, but what identifies it as a linear equation? Because even if it's not in this form, y equals mx plus b, where there will be a number right here at the m position, there will be a number at the b position. Those will be numbers. But how do we recognize consistently that we're looking at a linear equation? Well, it has to do with this exponent or this power on the x variable. That invisible power or exponent is always going to be a 1 because a linear equation is a first degree polynomial. So going forward, we may have linear equations that are not exactly in this form, but we need to be able to recognize that they are linear equations, and we will recognize that they are because they are first degree polynomials, and that means they will always have a power of 1. It will always be invisible, and that is how we can always consistently recognize that it is linear equation. Okay, so here we have our first question. It says it wants us to identify the slope and the y-intercept for the given equations. So here they've given us the equation y is equal to negative 5 halves x minus 5. And we can kind of see and recognize that it is in this format, y equals mx plus b. This number here is the m, this number here is the b, but I want to talk about for just a moment to reiterate this. The b, or the m, is the coefficient of the x variable. So we need to always consistently recognize that the m, which is the slope in math language, will be the coefficient of the x variable. The coefficient is the number that is in front of the x variable. So whatever number is in front of the x variable will be the m, or the slope. So we can easily identify the fact that this negative 5 halves is the slope. It is the m value. So that is the answer that we want here, negative 5 halves. Okay, and then we also need to find the y-intercept, which is the b. So the b, what do we know about the b? Well, the b is a constant. What is a constant? Well, it's just a number. A constant that does not necessarily have a variable with it. It's just a number. So the negative 5 here is just a number. It is a constant, and it is in the b position. So our y-intercept, which is identified as the number in the b position, is going to be negative 5. Okay, the next equation that they've given us to find the slope and the y-intercept for is y is equal to 3. Well, it doesn't look exactly like our y equals mx plus b, but we can think about this one a couple of different ways. So one of those ways is to realize that the b, the y-intercept, the b is a constant. Well, 3 is a constant, which means that would be in the b position. So we could say y is equal to plus 3, because that's a positive 3, so plus 3. So then actually what would be in the mx position? Well, if there's nothing there, what makes something nothing? The number 0. So technically that would be a slope of 0 times x, because what is 0 times anything? 0 times anything is just 0, and then it can just kind of disappear in our equation. So just from comparing y equals 3 to our standard linear slope-intercept form, we can determine that our m actually is 0 and our b is 3. So I could go ahead and just plug those in. My slope is going to be 0 and my y-intercept is going to be 3. However, there's another way to think about this. We can think about this, what does y equals 3 look like when we graph it? Okay, so let's pull up a X and Y axis here. Okay, so if I have y equals 3, it's just a y equals equation, and it is only going to touch the y-axis. So if it's y equals, it's only going to touch the y-axis. So that means that I'm going to go find 3 on the y-axis. So let's just say that there's 1, 2, 3. So right there is 3. And it's only going to cross that y-axis. It is going to be a horizontal line. And in another video, or you may have learned this previously, if you have a horizontal line, which is a flat line, that means that the slope is always going to be equal to 0. So that kind of confirms that there's no slope here. There's no hill. It doesn't go uphill. It doesn't go downhill. It's just kind of flat. And that is a slope of 0. And of course, the y-intercept, where is it touching the y-axis? Well, it is definitely touching the y-axis at the 3. So hopefully that gives you a couple of ways to think about this particular type of equation and what its slope and y-intercept will be. Okay, the next equation they have given us is y is equal to negative 5 plus 2x. It looks very similar to y equals mx plus b. It's not in exactly the exact order. So again, we just need to make sure that we think about the fact that the m is the coefficient of the x variable. So if there's the x, where's the coefficient? Well, the coefficient is 2. So m is going to be that 2. That is in the coefficient to the variable position. Slope is equal to 2. And of course, the b is going to be the constant, which is just a number by itself. So here I have negative 5 is the constant by itself. So that means that the y-intercept will be negative 5. Okay. Alrighty then. So now they've given us the equation y is equal to 1/2 x. And again, we can compare that to our standard favorite linear equation. And we can say that y is equal to some number, some coefficient in front of the x. Well, this is definitely a number in front of the x. So that would be negative or 1/2 x. And then plus b. Well, what is out here? Well, it's invisible. It's just a plus 0, because there's nothing there. So that means that we can identify that the 1/2 is in the m position and the 0 is going to be in the b position. So my slope is going to be equal to the 1/2 and my y-intercept is going to be equal to 0. Okay, our next instruction says first solve for y in the given equation, then identify the slope and the y-intercept. Okay, so remember earlier in the video, I talked about how do we recognize that we're always dealing with a linear equation. And if you remember what we talked about, it is this power on the x variable. If that power right there is an invisible 1, then it confirms that it is a linear equation. So we can use our favorite linear equation. Like I said, this is our favorite. We like this one because it gives us lots of information. That's why we love it so much. But we are going to do exactly what they said. They were going to first solve for the y. So basically, we're going to take this equation they've given us. We're going to solve for the y. And when we do that, it will turn into or convert to our slope-intercept form. So that is what we're doing. We're going to convert to the slope-intercept form so that it will be very easy to identify what the slope is and what the y-intercept is. That's why we love it so much, because when it's in that form, it gives us easy identifiable information. Alrighty then, so how are we going to do this? We are going to start out with our equation and we're going to say, how can I start getting that y by itself? My order of operations says that I need to undo addition or subtraction first. I want to get this term away from my y. So I'm going to do minus 4x on both sides, minus 4x. These will cancel out, and then I end up with 3y is equal to negative 4x plus 9. Now, if you notice, I put the negative 4x in front because I want it to match where my x term is going to be first and my constant is going to be last, just because it's easier for my brain to match it up if it's in a more perfect order. Okay, so now I still want to get the y. I'm solving for the y. I want to get that y all by itself. So the next thing I need to do is divide out the 3. So I'm going to divide this side by 3. And if I divide that side by 3, then that means I have to divide the other side by 3. So every single piece gets divided by 3. These 3's will cancel out, and then I have y is equal to negative 4 thirds x plus, and then 9 divided by 3 is going to be 3. So now I have my perfect y equals mx plus b slope-intercept form, and I can easily identify the fact that my m is going to be the negative 4 thirds. That will be my slope, and my constant right here, 3, is going to be my y-intercept. So m is negative 4 thirds, and 3 is my y-intercept. So those are my answers. Okay, our next equation that they've given us is 2y minus 10 minus 6x is equal to 0. And it's definitely not in our favorite slope-intercept form. But can we confirm that it is linear? Well, yes, we can. Here is my x variable, and the invisible power on that x is a 1 because x to the first power is just equal to a regular x without any power, the invisible power. Okay, we want to convert it to the y equals mx plus b format, which means that we are going to solve for this y. That's what we're going to do. Okay, so let's go ahead and rewrite this. I want to make sure I have plenty of room to work here. Okay, so I got 2y minus 10 minus 6x equals 0. Okay, so I want to solve for the y. That means I need to get the negative 10 away from the y. I need to get the negative 6x away from the y. So I'm going to do plus 10 and plus 6x because I want to move them to the other side of the equal sign. So that means I'm going to do the same thing to the other side of the equal sign to keep everything balanced and equal. Okay, so these will cancel out, these will cancel out, and that leaves me with 2y is equal to plus 10, except that I'm going to put the plus 6 in front because that matches up with my mx first in line and my constant second. So I'm going to put 6x and then plus 10, a constant last. And now I need to get that 2 away from the y. I need to use my order of operations rules, and I'm going to divide everything on both sides of the equal signs by 2. Okay, so these 2's will cancel. That leaves me with y is equal to 6 divided by 2 is 3x, and plus 10 divided by 2 is going to be 5. And again, it's very easy now to see what my m is and what my b is. It's the m is going to be 3 and the 5 will be my b value. So my slope is 3 and my b y-intercept is going to be 5. Our next instruction says to graph each linear equation using the slope, rise over run, and the y-intercept. So they've given us the equation y is equal to 4x minus 3, and we can see that it does line up with y equals mx plus b, which is our favorite linear equation form. Okay, so we can see that the m, or the slope, is equal to the 4. We can see easily that our y-intercept b number is equal to a negative 3. So we are going to use those numbers. We are going to plot the y-intercept first, and then we're going to use our slope to finish. So my y-intercept is the -3. So that means on the y-axis, here's the y-axis, I'm going to go find -3. So -3 is going to be down here, -1, -2, -3. So right there is my y-intercept at 3. So I've plotted my y-intercept. Now I'm going to use my slope to finish. Well, my slope number is 4. My m is equal to 4, but we can rewrite 4 as 4 divided by 1. There's an invisible 1 under every number in existence. So 4 is equal to 4 divided by 1. Does that make sense? 4 divided by 1 is equal to 4. So that gives rise to this statement right here, rise over run. The 4 is going to be my rise number, and the 1 is going to be my run number. And so in practical application, it means that rising is going up, like the y-axis. The y-axis rises to the sky. So that means that I'm going to go up 4, and then running, I'm going to run over the ground or across the ground. So it's going to be up 4 and over 1. So from this y-intercept, I'm going to go up 4, so up 1. It's like I'm going to go up 1 and 2 and 3 and 4. And then I'm going to go over 1. So I'm going to go over 1, and that is going to give me the second point that I need. So right there is my next point. And now all I need to do is connect those 2 points, and I will have a line. You only have to have 2 points to have a line. So right there, that is my line. This video has been brought to you by Connect the Dots Online Math Tutoring. Before you leave, click on the like button and the subscribe button, and have a wonderful day.